Alright, there are 4 techniques we're going to go through for doing limits algebraically. I'm just going to list them. Then we'll go into one at a time. So there's factor and cancel. There's expand and cancel. There's rationalize. And there are piecewise functions to worry about. Let's do piecewise first. So I'm just going to run through a bunch of examples and we'll go from there. How much with piecewise functions did you guys do last year? Dabbled?
We dipped our toes.
Okay. Okay. The water was cold, so we totally left. So I'll start by just kind of trying to describe what a piecewise, hopefully not kind of, but trying to describe what a piecewise function is. So, some people are still writing, so I'll wait a second. It's fine if you're still writing on it, just wait on it. Want to wait. Okay, so if I asked you to graph this, and you don't ever have to graph these, but I think if you understand the process of what is actually happening, you're a lot more likely to understand how to do the problems. So let's take a stab at it. I'm going to go down here, and you might not want to write until you see what I'm doing, because I'm going to write and then erase, and then write and then erase. So y equals x squared looks like that, right? Well, in a piecewise function, what they're saying is, okay, your graph is x squared, but that only applies when x is less than 1. So everything to the right of 1, it doesn't exist over there. I just erase it. And then at 1, am I going to put an open circle or a closed circle in y? Yeah, Mitchell.
Open circle.
Why?
Because x has to be less than y, it's not equal less than.
Right. So if it's over equal to, I'm going to put a closed dot. If it's just less than or just greater than, I'm going to put an open circle. So they're saying, okay, for this p, they're basically splitting the graph up into 2 parts. So to the left of this part, the graph looks like y equals x squared, which is that parabola piece. To the right, so when x is greater than or equal to 1. So I'm gonna graph 2x plus 4. I'm just gonna graph the whole deal. I'm not gonna worry about whether the dots connect, because that's what we're gonna try to find out with the limits. I don't want to get bogged down in the details of the numbers. But 2x plus 4, your y-intercept would be 4, so somewhere up here, you're going to go up 2 over 1, up 2 over 1. And this would be the line that you're drawing, but that only applies when x is greater than or equal to 1. It only applies to the right of 1. So I'm going to erase everything to the left. Is this open dot or closed dot? This would be closed because it's the or equal. And so you get these two pieces, and then the basic question is, do they meet or not? Like that's what we're going to be trying to get to at the end. But that's what a piecewise function is. You got part of a graph over here and part of a different graph over here. You could have 3 or 4 pieces too. And then we'll kind of try to see if they connect. So if I want to know the limit as x approaches 1 from the left. So just thinking about the graph from the left, like to the left of 1, which graph applies? The parabola or the line? The parabola, right? And just look up here, so just to the left of 1 would be a number a little smaller than 1, so doesn't it make sense that I would choose the one that where x is less than 1 to plug into? So just plug 1 into that, what do you get? 1 squared is 1. Actually figuring them out is way easier than graphing them. Just try to help you understand. 1 from the right, so now I want numbers that are a little bigger than 1, so it makes sense to plug into the one where x is greater than or equal to 1. So if I plug 1 into here, what do I get? 6. And you can see just from my graph, I mean, it was a sketch, but even on my sketch, like these were really far apart from each other. So do the roads meet? Do they come together? Nope. So what's the limit as x approaches 1 in general? Does not exist. And for f of 1, which one do you plug into? The top or the bottom? The bottom, why? Because it got the or equal to. You meant like the top piece. Yeah. Okay, yeah. So you're going to plug into the bottom equation. So f of 1 would be 6. How's that seem? Not bad? What? What'd you say? Haley, how's that seem?
Fine.
Okay.
Yeah.
All right.
Good.
It's a weird conversation.
Yeah.
It says, so again, I'll ask you the same questions, like what's the limit as x approaches 2 from the left, from the right, in general, and then what's f of 2? So I'm going to graph it again, just because you do not have to. So basically up here we want to graph y equals 4, and then down here we want to graph y equals x. That's just 2 equations listed. What does y equals 4 look like? 0 slope, which is what kind of line? Don't say straight, please. Horizontal. So y equals 4. A lot of people say that. Looks like that. But at negative 2 is like the cutoff point. So I only want that to be true to the left of negative 2. So I'm going to erase that other part of it. Open dot or closed dot here. Closed because it's got the or equal attached to it. What does y equals x look like? Slope of 1 through the origin. That's like that 45-degree line, right? It cuts up perfectly through that. So we get this. But we only want that to, oh, wait, sorry. There should be a negative sign here. Otherwise there's like a giant gap between those. This 2 up here, there needs to be a negative sign. Sorry. So we only want this to be true to the right of negative 2. Open circle, right? Because there's not the or equal to there. And I didn't make my graph like super precise, but I can kind of tell already what's the limit going to be as x approaches. And I put 2's everywhere in that. These should all be negative 2's. I apologize. So make every x value and all, there's like like 6 spots where they're all negative 2s. So again, I didn't like precisely graph this, but what's it look like the limit's going to be as x approaches negative 2? Does not exist because those aren't meeting; they're not coming together, right? Negative 2 from the left side, so I want numbers that are less than negative 2, which means I'm going to plug into the one where the numbers are less than negative 2. So if I plug in negative 2 into the equation 4, what do I get? I get 4. There's no x value to plug into, so it's just 4. No matter what the x value is, your y value is 4. That's how you get that horizontal line. Negative 2 from the right, so I want numbers that are a little bigger than negative 2. So I want to choose the equation where x is greater than negative 2. If I plug negative 2 into x, I get negative 2. At negative 2, the limit doesn't exist because they're different. These two are different. They're different values. And what's f of negative 2? Well, I'm going to plug into the top equation or the bottom equation? Top equation because it's got the or equal. So that would be 4. Questions on that? Yeah.
For letter B, you plug in negative 2 for the bottom equation, but it has to be
I agree. So that like what you said is accurate. So I'm not sure what like
Isn't it just the
that
limit? Isn't it just the value that has to be greater than negative 2, and the limit can still be negative 2? Because we're finding the limit, not the value. Because there would be no value if you plugged it in. Because it doesn't have the or equals. That's why you plug it to the top.
Oh, is that what you're trying to say?
Yeah.
Okay, so remember, it's not. We don't really care about the value. You're right. Plugging in was the wrong way to. Look at the graph. So what does it look like the y value is going towards? Negative 2. And so you're saying why do you plug in if negative 2 if that doesn't apply? So imagine we're plugging in a number slightly bigger than negative 2. Let's say we plugged in negative 1.9. What would we get? Negative 1.9, right? Let's say we plug in negative 1.99. That's what we get. Plug in negative 1.999. That's what we get. So the limit as I get to 2, like what does it look like the y value is going towards? Is negative 2. And in this case, you can just plug in because there's nothing else goofy going on. There's not like a 0 over 0 situation or anything like that. Does that answer your question? Okay. Sorry, I didn't catch on at first what you're asking. We're good? Okay. Let's look at a little different situation now. That was a really good question. I just didn't catch it at first. So this is a little different. If you start plugging in, I think you'll see why. Yeah.
You have 2 less than signs.
Yeah. Let's make that top one greater than or equal to. So if I look at the limit as x approaches 3 from the right, we want to plug in numbers that are a little bit bigger than 3. Is that the top equation or the bottom equation? That's the top one. If I plug 3 in there, what do I get? 4. X approaches 3 from the left, so we want to plug in numbers that are a little less than 3, so we're going to choose the bottom equation. Do you know what I mean by plug in that? Like that, right? So if I plug 3 into the bottom equation, what do I get? 4. So what's the limit as x approaches 3? 4. What's f of 3? 4. So this one, they will actually connect. So you get a situation like this, where the two graphs do come together. So you got those two rows. The first two we did, they didn't meet, so the limit didn't exist, and this one they do. Okay. Questions there? Can I move it, or are people still writing stuff down? We're good? Okay. So the fourth kind of situation is usually the most confusing for people. Let's say k of x equals x squared minus 9 when x does not equal 4. And 17 when x does equal 4. So to understand this, I think it's best to look at the graph. You don't have to graph them, but I think it'll help you understand what's going on, so I'm going to. So what this means is this is our equation. So basically this is y equals x squared minus 9 with a hole at x equals 4. That's what that means. X squared minus 9 is the equation the entire way, except at 4 there's something weird going on. There's an open circle there. So x squared minus 9, got a y-intercept of -9, it'd be a parabola. It's got like a hole there. But everywhere else is totally normal, and you get a nice smooth parabola, except for at that one spot. If I were to plug that hole, you okay? If I were to plug that hole, what y value should I use to plug it? Like what is the y value of that hole? Forget that's even there. I know why you're confused. I put the freaking axis in the wrong freaking spot. Let's start this graph over. Can we start the question over?
Yeah.
Sure.
I'll make one with not such a giant number. Sorry. X squared minus 2 when x is not equal to 3. 4 when x does equal 3. So what this means is y equals x squared minus 2 with a hole when x equals 3. And what this means is there's a point at 3, 4. And so the question becomes, does that point fill in the circle, or is it somewhere else above or below it? That's like what we're going to be getting to in a second here. So if this didn't exist and I wanted to know the y value when x is 3, what would it be? Like if you just plug 3 into that, what do you get? 7, right? 3 squared minus 2, so 7. So this dot has a y value of 7. but it's an open dot because we got this x is not equal to 3 here. This is like the attempt to build the bridge, but they built the bridge in the wrong spot. This bridge at x equals 3 has a y value of 4, so it's like down here. Let's go through our questions. What's the limit as x approaches 3 from the left? 3 from the right? 3 in general? Roughly okay? We good? Questions? So the big thing to realize is, like the ones we've done before, there was like a road, and like, are those two roads going to connect or not? There's only one road in this one. There's just one giant road. It's just got like a gap in it. So when I go x equals 3 from the left, I'm going to plug into this road, because this road applies everywhere except for like that one tiny spot. When I go x approaches 3 from the right, I'm going to still plug into this one, because that road applies everywhere. So like, what y value does it look like we're heading toward if I come from either side? 7. So this is 7, this is 7, this is 7. And then what's f of 3? 4. Sometimes they'll do this and they'll put like a variable here. They'll say this is m. And they'll say find m so that the function is everywhere continuous, which we haven't even learned that word yet. But let me just ask you this way. What would the y value, what number would we put here to build the bridge in the correct spot? 7. So that concept we'll use with different vocabulary in a couple days, but that concept we can do now. Let's do another one of those. So again, this means y equals 2x minus 3 everywhere except a hole at x equals 0. And this means a point at 0, 1. So like the main question is, does that point is that point in the right spot? Is it? I think you can tell already. Is that point in the right spot? Is that the correct y value that would fill in the hole? It's not. So if I plug 0 into that top equation, what do I get? I get negative 3. So I'm going to have a big road with a gap at a y value of negative 3 and a point at 1, and they're not going to be in the same spot. Again, you don't have to graph it, but if I did, 2x minus 3. So this is my y-intercepts. Go up 2 over 1, 2 over 1, so I get something that looks like that. And there's just a hole when x equals 0. It's just missing. It's just like somebody was trying to build a bridge over the river and forgot, and built the roads that came to it, but forgot to build the bridge. And then someone else came along later and was like, oh, I'll build a bridge. But they put it up here at x equals 1. Set up in the right spot. What would the right spot be? Negative 3. But that's not what this equation says. It tells us at 1. So based on this, we got to be able to answer these questions. X approaches 0 from the left. X approaches 0 from the right. X approaches 0 and f of 0. So go ahead and do those 4. What's the limit of x approaching 0 from the left? -3. And realize, like, you can make the graph if you want, but realize you're really going to usually be doing that without the graph. Does that make sense still how to do it without the graph? The biggest thing to realize is there's only one road to plug into. This is just a bridge. It's not an entire equation. It's not a road. So this is -3. So because these are the same, this is -3, and then this is 1. Is the function continuous at x equals 0? We haven't quite got there yet, but continuous means the limit and the value are the same. And this wouldn't be because that bridge is in the wrong spot. If I had said at the very beginning, find k to make f of x continuous, basically that's saying what value would you have to put here to build the bridge in the right spot, and what would that be? Oh, okay. Does this help?
Yeah, now it makes sense, but it was so much more complicated.
Okay.
Con has a large tendency to overcomplicate.
Sometimes
Their
yeah.
explanations are like.
Sometimes they're really good, and sometimes they're.
When that question is like, well, we know this, this, and this. I'm like, okay, how?
Okay.
I know we do.
So does this help?
Yeah.
Is that, okay.
Yeah.
Okay. So there's like I told you, there's those 4 kinds of algebraics we're gonna do. All we got through today was piecewise, and that's totally fine. But there's all 4 kinds on here. Just do the piecewise ones on here. So find all the ones that have a piecewise function, just do those,